Let's say find the area between the curves f of x equals blah and blah, that interval blah. If you would, good student, graph these individually on your calculator and change your window so the x min is 1 and the x max is 4, because that's all you care about. So put one function in your y1, put the other function in your y2. And then, wow, I don't know what I was doing there. What did I say, 1 to 4? With a scale of 1's fine. We can just say negative 10 to 10. Now, for the area between the curves, if your functions cross the x-axis, it doesn't matter at all. You're only caring if they cross each other. So graph, okay, there's your quadratic. There's your linear. One's on top of the other. Which one's on top? F of x. So when you go back, hey, it worked. So when we go back to write our integral from 1 to 4, we put f of x first. And then we subtract g of x. Since g of x is more than one term, what do we need to put around g of x? Parentheses. You could tell that because I already wrote it down. So you could have just said parentheses. Hello. That's going to be fun to edit. Okay. So let's clean this up. If you want, you can distribute your negative through first. So we'll get 2x plus 1. And instead of having to take 5 integrals, we can just take 3 because numbers combine here. How many total x's do we have? 6x. And constants? Is that okay? What is what?
How did you know which the function was?
First, sure. Well, the order in which you have it in your calculator is the order in which it graphs.
Oh.
What you can do, let me show you this, is if in your y equals, you scroll all the way to the left, where that little guy is highlighted. If you hit enter once, instead of drawing a regular line, it'll make it full. So now when you hit graph, that's another way of being able to differentiate between things. Ding, ding, ding. All right, what is the antiderivative of negative x squared? Negative 1/3 x cubed. What's the antiderivative of 6x? X squared. And what's the antiderivative of 4? 4x. We're evaluating that from 1 to 4. If you took the derivative of this, you should get back your integram. You should be doing that every time you integrate. So we'll stick in 4, we'll subtract, we'll stick in 1. I got 36. Did you get 36? Yeah. That's nice. Alright, so that's basically it, honestly. They could get worse only if they cross, but it's just top minus bottom. Find the area between the curves f of x equals x squared and square root of x. Oh, I lied. They can get worse because they cannot tell you. So we need to graph these to figure out where they cross. So go into your calculator. Go into your y equals. I don't know why I'm turning around. It's right in front of me. Clear. x squared, square root of x. Okay. As far as the window, if you just go to zoom 6, that'll be fine. So here comes the parabola, here comes the square root function. Oh, it's so close. So we're going to have to zoom in a little bit more. Actually, a lot a bit more. So let's go to your window, and let's just make everything negative 3 to 3. So the moral of the story is, you may not know what the graphs are going to look like. That's fine. Just adjust your window. And now hit graph. Parabola, square root. So that little leafy shape guy, that's the area of where we're needing to find. So we have to figure out where these functions intersect. I'll just tell you the lower one's at 0. And we'll do the upper one by hand. Not by hand, but by calculator. So actually all these intersections you can do by calculator. You don't have to show the work. Now don't take that as, I don't have to show the work for anything. No, that's not what I'm saying. So once these are two graphed, you want to go to second, calc. And number 5 there is intersect. I went too far. And hit enter. It's going to ask for first curve. Well, we only have 2 functions that we're graphing. So for first curve, hit enter. For second curve, hit enter. And for guess, well, notice it intersects twice. So we have to tell it which one we want. I already told you the one at the origin. So let's go to this one over here. And just hit enter. How nice. 1, 1. Well, that should make sense because what's 0 squared? What's the square root of 0? So that explains 0. What's 1 squared? What's the square root of 1? 1. So those are the only 2 numbers who their own squares and square roots. 0s and 1. Awesome. So we're going to integrate between 0 and 1. Now, I already took my screen off, but which function was on top between 0 and 1? Huh? Not between 0 and 1. The square root was on top, right, because it curved up. So x squared, square root gets written first, and x squared is second. What's the n for the square root of x? What's the exponent? There you go, 1/2. So, we will have, I'll write this one out because this one's a little bit harder. 1 over 1/2 plus 1, x to 1/2 plus 1, minus, this one's nice, 1 over 2 plus 1, x to 2 plus 1. And we're going to evaluate this from 0 to 1. What is? 1 over 1/2 plus 1. 1/2 is 3/2, so what's 1 over 3/2? 2/3. Fractions are your friend. Yes, they are. Minus 1/3, x to the 3rd. Plug in 1, plug in 0. What do you get? Anyone? 1/3, thank you. Good job.